All right, we are going to continue. This one's a doozy. So first of all, I want you to notice that this denominator can be factored. So this is the difference of two squares. So because I have this magical thing that erases, I want you, because I'm running low on room. So we're just going to say that that's an x plus 3, x minus 3. So rewriting my x squared minus 9, I have an x plus 3, x minus 3. And now I need to figure out how many things I've got. So I've got this being multiplied. I've got this being multiplied. Okay, I've got this being multiplied. And I've got this being multiplied. But we also need to recognize that we have a square root going on here. That square root only belongs to my numerator. And remember, I can write a square root as a power of 1/2. So I'm going to go ahead and write this out. So I'm going to give each piece, I'm trying to figure out the fastest, easiest way to do this for you. All right, so I've got log base 5 of, this is going to have a piece and this is going to have a piece, and they're both going to lead off positive. So I've got an x minus 1 plus log base 5 of x plus 2 minus, because I'm going to drop to the denominator, log base 5 of x plus 3. I'm running out of room. And then minus log base 5 of x minus 3. Now, we haven't incorporated this square root yet. So looking over here, what I have is x minus 1 times x plus 2 is all raised to the 1/2 power. Okay, so this, I can distribute that power because this is multiplication. So this has a 1/2 and this has a 1/2 because they both have a square root. So the final thing I'm going to do, writing very small, is I'm going to drop those two exponents out front. So this now becomes 1/2 log base 5 of x minus 1 because he's under the radical. So he gets the 1/2. Plus, because this is multiplication, 1/2 log base 5 of x plus 2 minus, because I'm dropping down and these are not under the radical, so they do not get a 1/2, minus log base 5 of x plus 3 minus log base 5 of x minus 3. So I've got my multiplication, drop to the denominator, drop to the denominator. And then I have my square root, which is actually a 1/2 power, that belongs to both of these factors. And I brought them out front. Okay. This one I'm going to condense. Okay. So if it goes in the numerator, I'm going to highlight it in green. So he is leading off positive. He's leading off negative. He's going to go to the denominator. He's leading off positive. He's going to go to the denominator because he's leading off negative. So the greens are going to be in the numerator of the argument, and the yellows are going to be in the denominator of the argument. But all of this can be rewritten with a single logarithm. Your base is not written. So this is a common log. What is your base? Your base is 10. Okay, so I'm going to go ahead and get these two first. So I've got log, or the common log, of 3 times 5. Okay, and then this is going to be over. Well, one of the things I've got to do is I've got to kick up that coefficient. So this coefficient becomes 4 to the 2/3 power. This coefficient gets kicked up, and he's a power of 3. So I have 4 to the 2/3 power times 6 to the 3rd. Okay, so what can I do to clean this up? This is going to stay ugly. This 4 to the 2/3 is going to stay ugly. Okay, but 3, 5, and 6 to the 3rd I can clean up. So that's a log of 15 over 4 to the 2/3, and then 6 to the 3rd is going to be 6 times 6 is 216. And there you go. And I would leave it like that. You can actually reduce this by a single 3, so you would have 5 over 72. So let's just write that. You would have a final answer of log of 5 over 4 2/3 times 72. That is your answer. Can you see that? Okay, let me write it down here. You will have the common log of 5 over 4 2/3 times 72. Okay, so leave that as 4 2/3. This one, so let's highlight again. If it goes in the numerator, because it leads off positive, this is a positive one. That's a positive. That's a negative. So these ones are responsible for residing in the numerator. Okay. This one is responsible for residing in the denominator. And I'm actually going to write this out an extra step because I kind of sort of squished these ones. So I am going to write this as log base 4 of x minus 1 plus log base 4 of x minus 2 minus, I'm going to kick up my coefficient. So that becomes log base 4 of x plus 3 to the 1/3. So now these can go in my numerator, he can go in my denominator. So I have a single logarithm in base 4. My numerator will have an x minus 1, x minus 2. My denominator, I can either write that as x plus 3 to the 1/3, or I can remember that he is the cubed root of x plus 3. So it's x plus 3 to the 1st, but you're taking a cubed root, and it only belongs to the x plus 3. Okay? So we are now going to use properties of logarithms to come up with a final answer of what these look like. So first of all, recognize you're working with base 2. I've got 2 separate logarithms. I've got arguments of 4 and 1/8. And my logs are joined by subtraction. He's leading off positive, so he'll go to the numerator. He's leading off negative, so he'll go to the denominator. So rewriting that as a single logarithm gives me log base 2 of 4 over 1/8. Okay, so I'm dividing by fractions. So I want to go ahead and write this one as a fraction. So that's 4 over 1 divided by 1 over 8. Okay, continuing on, when I'm dividing by fractions, I change it to multiplication by the reciprocal. So now I've got log base 2 of 32 over 1 that I don't care about. So here's your question. 2 raised to some power is 32. What's the power? How many times do I need to multiply 2 by itself to get 32? So 2, 4, 8, 16, 32. So 2 to the 5th power, remember I can always slap an equals x on there. 2 to the x power is 32, and that power is 5. So this whole mess that I started with simplifies down to 5. Okay, not 5x, just 5. All right, so let's do it again. I have 2 separate logarithms joined by addition. So it's going to be multiplication problem on the inside. So I need to kick up my coefficient first. So this is going to become log base 16 of 4 squared plus log base 16 of 1 over 256. Okay, so I've got 2 separate logarithms joined by addition, so I'm going to write it as a single logarithm. Log base 16 of, I'm going to go ahead and clean this up. What is 4 squared? 4 squared is 16. Over. And I said over because I'm going to multiply it by 256. So let's do this. Let's do 16 over 1 times 1 over 256. So this is my 16 in the numerator. This is my 1 over 256 in the numerator. Okay, so it's just multiplication straight across. So I get a 16 over 256, which reduces to 1/16. So I have log base 16 of 16 over 256. That's log base 16 of 1/16. Okay, so what power do I raise 16 to get an answer of 1/16? Well, let's bring that 16 to the top. So I've got log base 16 of 16 to the -1. And now there's a couple of different things I could do here. I can drop that exponent out front. So that gives me a -1 times log of 16, log base 16 of 16. If your base and your argument match, all of this turns into a 1. So -1 times 1 is -1. So this right here was a very long way to write -1. So what happens if I need change of base? My calculator only knows base 10 and base E. So sometimes we need to trick our calculator and get some decimal approximations. So I can do this one of two ways. Your instructions are to use the natural log. I'm going to show you both ways. So change of base simply says, let's change it to a base my calculator knows. My calculator knows base 10 and base E. So I'm going to take the log of the argument, so the common log of 15, notice I just changed it into base 10, and divide it by the common log of the base my calculator doesn't know. Okay? Now, I could also do, and these are your instructions, I could use the natural log. So I could say the natural log of 15 over the natural log of 7. So let's look and see what happens. If I use the natural log of 15, close that argument, divided by the natural log of 7, close that argument, and then hit enter, I get an answer of 1.3917. It says, hang on, how many decimal places? We are going to, okay, well, we're not. Okay, I get 1.392. So this is 1.392. If I use a common log, I have the common log of 15 divided by the common log of 7, and I get 1.392. Okay, so this is also 1.392. Bottom line is it does not matter. But our instructions are to use the change of base formula with the natural log and just write it as a ratio. So this is my final answer. Okay, that's my final answer. I wanted you to see that the decimal gives you the same thing. But this is your final answer to write this. So let's try this one because I can't put this in the calculator. Okay, so my calculator doesn't know base x. So I am going to write this as the common log of y over the common log of the base my calculator doesn't know. So the argument goes in the numerator, the base goes in your denominator. That's not what we're using. We're using the natural log, but we just showed that those are the same things. So this is actually going to be the natural log of y over the natural log of x. And that is going to be my final answer. You cannot reduce that to the natural log of y over x. Don't do that. Okay? You're changing a base. And that is your lesson for this module.